going to discuss about important topic, that is kinetic molecular theory. This is a famous theory that was proposed in this chapter, States of Matter, and it discusses mainly about ideal gas. So what is ideal gas we will be understanding after finishing this topic. So kinetic molecular theory, from the terms itself we can understand kinetic, something that is in motion, okay? Molecular theory, that indicates the gas molecules which are in constant motion. To understand this theory, there are mainly 5 postulates that we will be going through. Let's consider a room which is filled of ideal gas, okay? Ideal gas. Ideal gas, for example, any gas you consider, okay? Any gas which is non-reactive, and be it in a room, it is filled with ideal gas. So let's consider helium gas, for example, helium. So helium molecules will be in constant, helium atoms will be in constant or random motion, yeah? So the first postulate states that if ideal gas is filled in a particular closed container or a room, we can say that the particles will be identical. That means all the molecules of helium will be identical to each other. So that's the first postulate. Now there's some fact that we should observe in this is that some of these postulates are already proposed, but they are having limitations. So we will be understanding the limitations along with the postulates, okay? So first postulate is that all the particles of that gas is identical. That is correct, because helium particles or helium atoms will be always the same when it is present in a closed container. That's obviously correct. Then let's see the second. The force is 0. That is, there is no force of attraction between the helium particles. This was a postulate which was given, but is that postulate actually correct? No, because we know that even though there is no reaction or there is no bond between helium atoms, there always exists a force that is known as van der Waals force. So van der Waals force is actually existing, but this kinetic molecular theory did not consider that force. So this second postulate is incorrect. But we should mention that postulate when we are studying kinetic molecular theory, because the limitations of this topic led to the discovery of some other topic that we will discuss later. So the postulates we should understand. Second postulate was there is no force of attraction between the particles when they are present in a large container. So obviously you know van der Waals force is very negligible. So this theory actually neglected that force. Van der Waals force also they neglected. So what is the limitation of that postulate? When we are going to compress the gas, then the particles or the helium will come closer to each other. So when they are coming closer to each other, obviously we know that force is inversely proportional to distance raised to the power 6. So when we are decreasing the distance, that is when we are applying pressure, so obviously they come closer. So distance decreases, force increases. So force equal to 0 is a false statement. So second postulate is not always correct, but it can be considered when the room is closed and it's very big. So that van der Waals force is negligible means it is okay. But otherwise it is not universally acceptable. Let's see the third condition. Random motion. The particles of a gas are always in a state of random motion. We are considering non-reactive gases, okay, over here. So helium particles which I am considering, they are always in random motion. This helium particle 1, helium atom 1, helium atom 2, they will be in random motion, random zigzag motion. They will be colliding with each other, or they may collide with the walls of the container also. So that is indicating by random motion. That is correct. So this postulate is absolutely correct. This is also correct. This postulate is correct, but it has limitations. So it is not universally acceptable. So this is limitation, okay? Then fourth postulate, it is perfectly elastic collision. From the term perfectly elastic, you should understand what is the meaning of it. It's a physical term. Perfectly elastic means momentum and energy, kinetic energy, are conserved. That is, when the helium particle is going and hitting to the walls of the container, then the momentum of the helium particle or momentum of the gas molecule and the kinetic energy of the gas molecule both are conserved. Conserved means it is not lost. Initial momentum and final momentum remain the same. Law of conservation of momentum, law of conservation of energy is applicable for this gas or non-reactive gases, ideal gases, when they are considered, okay? So it's perfectly elastic. So this postulate is also correct. Now velocity and energy are different. Let's consider 2 helium atoms or any 2 gas molecules. So 1 and 2. This is gas molecule 1, this is gas molecule 2. This molecule is moving in some other direction, and this may be moving in some other direction with different velocities. So velocity of first one be v1 and velocity of the second be v2. If their velocity is different, then obviously their energy also changes, because energy is equal to half m v square, half m into v square. Mass is constant for helium particles or any gas molecule. So velocity changes. Velocity is a vector quantity. If the speed also remains the same, still velocity can change, because it's direction. Direction changes means velocity changes. So energy changes. So we can say that velocity and energy are different. So we can say this postulate is also correct. But due to the limitation, that is the second postulate is not always true, this kinetic molecular theory is not universally acceptable. Why? Because of the second postulate. That can be corrected also. That correction to the second postulate is what we are going to study later. So in this module you have already studied what are the 5 postulates of kinetic molecular theory and what are the limitations of that. So limitation is force of attraction. There is a vague concept regarding the force of attraction that we are going to discuss about it in the next video. So please like, share and subscribe.